So in the previous video, we talked about why this might be a good idea for the form of a separable, the form of a logistic equation, or the form of population growth, a model for population growth, where R is the rate of growth. Whoops, this isn't supposed to be an R, it's supposed to be a Y. R is the rate of growth, Y is the population size, K is your maximum population, 1 is just 1 because we care about the ratio. We talked about that. So we're actually going to solve it. This is a pretty long solve, but I want you to see it. So we know that this is a separable differential equation. We should be able to look at this and realize if we multiply this out, this would just be a y squared thing. So this is like a quadratic equation with a derivative in it. But that's what this is. If we were to multiply this out just so that we can see it, we would get ry, r is a constant, minus ry squared over k, where r over k would also be a constant. And we can see, like, it's just a quadratic equation. So when we have a derivative equal to a quadratic, we're talking about a logistic equation. Anywho, so what first step is we need to separate this out and make the dy's go one way and the dx's go the other way. So I'm going to say dy equals dx. I'm separating that out. I'm going to bring this whole thing over here and just basically by dividing by it. There we go. So I divided both sides by this big complex thing. So over here I have the number 1. And we should be able to look at that and go, uh-oh, that would be a quadratic underneath, so we need to do partial fractions. So here we go, partial fractions it is. So I'm going to rewrite this and say that this thing here equals is the same as 1 or a over ry plus b over 1 minus y over k. Well, I guess I'll just leave that out for now. So this is the same as that, and this whole thing, well, the a and the b have to be the same as the what's on the top. So that has to all become equal. So I'm rewriting this to be this, and that has to equal that. So now we can multiply this by this and that by that and say that that whole thing equals 1. So I'm going to multiply and distribute at the same time. So I'm going to get a minus a y over k plus b r y equals 1. All right. So I just found a common denominator, multiplied it, and did it. And now I know that this is 1 plus 0y. So this and this, I guess I should have included that negative sign, have to equal 0. Negative a y over k plus b r y equals 0y. The y's cancel out. So that's one of my equations. My other equations is as simple as a equals 1. So that's nice. A equals 1. So I'm going to rewrite this and go, well, now a is 1. Negative 1 over k plus b r equals 0. I got to add 1 over k to both sides. b r equals 1 over k. And therefore, b equals 1 over rk. Rk. Great. That was a bit of work. But now we know that this side of the equation can be rewritten as a, which is 1, over ry, plus b, which is 1 over rk, times 1 over 1 minus y over k dy, because that's dy right there. Whew. So we just rewrote that equation. And now at this point, what I'm going to do is erase this work underneath here. And start solving this. We are at a point where we could actually just integrate this directly. Some people might want to clean this up a little bit, but I don't think we need to. Well, if we multiply by k over k, we could get rid of that. And then, yeah, let's clean this up a little bit. So, equals 1 over ry. Actually, I'm going to rewrite that as well. 1 over r times 1 over y, because 1 over r is a constant, plus this term right here. I could multiply this term by k over k if I wanted to. And if I did that, I would get my first term, which is that, times k. I'm going to do this in color. K over k, whoops, let's do it this way, k minus y k over k. So those k's cancel out. Now we have this k over that k. Well, this k and this k can cancel out. So we can rewrite this as 1 over r times 1 over y. I forgot to bring down my dy. Plus 1 over r, this one, times 1 over k minus y, dy. And we have our 1 dx on the side. So we have separated, and now we are ready to integrate. Some of you might look and go, oh, look, 1 over r, 1 over r. I can pull that out front, and we are totally going to do that and go from there. So this left side is super easy. The integral of the left side is x plus c. I'm putting my c over there because that's just an easier side. The right side looks more complicated right now, so I'm just going to leave the c on the left side to ease up pressure over here. This, we know that the integral of 1 over y is the ln of y. So this, well, and we're going to factor out the 1 over r. So I'm going to do this. Integral of that is ln of y. The integral, and this r, 1 over r is also factored out. So the integral of this is negative ln of k minus y. Awesome. So we are getting there. So now our goal is to, as always, is to solve for y. So we are going to multiply everything by r. So I'm going to multiply, get rx plus rc. Well, r times c is still just another constant, so we'll just leave that as c. And then we have this. We might remember that we are able to combine ln's because it's a subtraction, by bringing it inside and turning it into division. So this turns into the ln of y over k minus y. Now we raise everything to the e. And when we do that, the left side turns into e to the rx times e to the c. Well, e to the c is still just another constant. So we're just going to call that c. And then on the right side, the ln and the e cancel each other out. They're inverses of each other. So we do this. The next step, we got to get y by itself. So we're going to multiply everything by k minus y. And when we do that, we end up getting our k minus y over here. I am going to now distribute this e to the rxc times k minus y, and I get ck e to the rx minus cy e to the rx. And on the right side, I just have a y. But notice I have a y on the left side too. So that means now I need to add this term to both sides. So I'm going to bring this y back over here. So I'm going to end up getting a plus cy e rx, and that goes away. Now what I'm going to do on this right side is I'm going to factor out this y. I know it feels like we're kind of like doing and redoing and doing and redoing, but that's kind of how this goes. Y times 1 plus c e rx equals c k e rx. So I just brought that down here, brought that over there. Let's factor out the y. So now I can divide both sides by this. 1 plus c e rx. That is my y. I am 99.95% done. I am going to bring this back up to the top so you can see the last step. Since we started here, I'm just going to bring it into there. I'm going to change colors so you see that there is something that's happened. We've got this thing here, and we have c k e rx over 1 plus c e rx is y. So I copied that right. Here's the last little thing that you can do that you'll often see. I can multiply the top and the bottom by 1 over c. C is just a constant, right? So I can do this, right? I can do that. That means that this c cancels out with that c. So that c is gone. This c, this 1 is going to turn into 1 over c, and then this c is going to be gone too. So I'm going to do this. Turn that into 1 over c, and that's going to be gone. So now we have k e to the rx, this part, over, and I'm going to ignore this just for a second, e to the rx equals y. And I'm going to point out that 1 over some random constant is still just another constant. So that turns into c. So this is the solution to the separable differential equation that's set up this way. I know that was long. I know that was challenging. I hope that you gave it a try. Anyway, bye.